Cedar Osorio. I'm a recent graduate from ODU University. I received my Bachelor of Engineering Technology degree. I'm also a recent retiree from the United States Navy of 25 and a half years. I've worked with Dr. Singh here for a few months now on the robotic arms project. This can be a demonstration using three RF 2.4 gigahertz modules, MRF 24J40MA to be exact, on a PIC training system for implementation of one master unit and two slave controllers and intercommunications. I will demonstrate a simple wireless data transmission from one master unit to two slave units. Now all three units will be identical with the exception of the master unit, which can have a keypad to generate the desired data to be transmitted. Now each unit is going to have the MRF 24J40MA. It's going to have a PIC 16F8778 microcontroller and an LCD, all mounted on a PIC microcontroller training system. Using a standard MRF 24J40MA, which have been slightly modified. We added the pins on here to be used on this PIC trainer board right here. And it will be controlled by the PIC 16F8778 microcontroller. Richard?
I'm Richard Sirianni. I'm a senior here in the Electrical Engineering Technology program at Old Dominion University, working with Dr. Singh on several projects and working with Latchy and Matt on this particular wireless project. As Latchy mentioned, we're using the MRF 24J40 2.4 gigahertz transceiver. This transceiver is compliant with the IEEE 802.15.4 standard. It uses a 4-wire SPI communication protocol, and it's got a range of approximately 400 feet. Back to Latchy.
Now eventually this network is going to have one master unit communicating with 5 slave units, each of which is going to be controlling one motor of a robotic arm. So to that end, the intent of this demonstration here is to transmit to each of the 2 slave units individually and to verify that only the intended unit receives the data. Now a critical step in establishing the wireless communication is the initialization of the RF chip. We have used for this demonstration for a non-beacon enabled network the standard RF initialization, which is indicated in paragraph 3.2 of the MRF 24J40 datasheet. Now also during this initialization procedure, each RF chip is going to be assigned a unique long and short address and a PAN ID, which will be common to all the chips in the network. Now in the master unit, the program can be a main program which is going to call the LCD and the RF initiate routines, and then going to go into a keypad routine in which it will sit until we get all the input that we need. In the slave unit, it will be similar. It will call the LCD and the RF initiates, and then it will go into a read subroutine and wait for the data to be received. Now when power is first applied to the master unit, you will have LED 4 illuminate, and LED 3 can be flashing, indicating SPI communication. Now towards the end of the initiation routine, you see on the LCD screen will be the PAN ID 9876 and the short address 1234. Now in the keypad subroutine, it's going to store all the results of the 5 key presses. Now once all 5 numbers have been entered, the program is going to go into the transmit routine, and LED 6 is going to be illuminated, indicating that. And also LED 3 will be flashing, indicating SPI communication. Now once the transmit is complete, you'll see on the LCD screen it will display data sent and the 5 digits that were entered and transmitted. Matthew?
My name is Matthew Henderson. I'm a senior here at ODU, also in the Electrical Engineering Technologies department, and I'm going to be discussing the slave units and their initialization. Now, when a slave unit is first initialized, you'll see that LED 3 begins flashing, indicating that SPI communication has initiated, and will again display our PAN ID along with the short address. After that, LED 5 illuminates, indicating that the system's in its read routine and it's ready to receive data. Now on the receiving unit on these slave units, once the data is received, pin RC7 is going to go low, and LED 5 is going to extinguish. LED 3 will begin flashing to indicate that SPI communications have initiated. Once the receipt is completed, the data will be displayed on the LCD saying data in. Now, in order to transmit the data, data has to be packaged in a specific format. The IEEE 802.15.4 standard defines four frame types. For this demonstration, we're going to be using the data type. The data packet contains 1 byte, which defines the entire length of the packet. That's followed by 2 frame control bytes, 1 sequence byte, 2 bytes for the destination PAN ID, followed by the destination short address, and then the source PAN ID, followed by the source short address. And then that's going to be followed by the data itself, which in the case of this demonstration is 5 bytes in length. Once data's been sent to the transmitter itself, it's going to be stored in the transmit FIFO beginning at hex 000. At that point, we're going to set the transmit normal FIFO control register bit 0, and the data will, the entire packet will be transmitted. On the receiving end, the data is stored beginning at address hex 300, and these are the addresses that are going to be read and stored in our GPRs for display at the LCD. Lachi?
We're now ready to initiate a transmit demonstration, so I will initiate that by depressing 5 keys here. 1, 2, 4, 5, 6. You see LED 3 flashing, SPI communication. Once that's done, you see LED 6 coming on. Now we're in the transmit routine. So right now, Matthew should be receiving a message over there right now. Matthew?
See, we received our data in 1, 2, 4, 5, 6, and we'll initiate this a second time so that you can see the entire procedure take place. But our data was received, and Lachi's going to send a second packet. And that just got sent. Now as it's coming in, we're going to see LED 5 extinguish. LED 3 will begin flashing, and then our data will be read in and displayed. Data in 1, 2, 4, 4, 5. Richard?
Lachi will now send a second packet that will go to the slave 2 board. And we received that as he sent us 47856. And he's resending now. You can see LED 3 is flashing. LED went out, and we're showing new data sent as 47855.